All right, we're going to continue our discussion on Riemann sums. So let's suppose we have f is a continuous function on the closed interval. It's differentiable on the open interval. And let's suppose that we have partitioned. Remember, every partition we discuss now is a regular partition. So we have partitioned the interval, and we have the subintervals formed, and out of each subinterval we choose a c sub I, a value in that subinterval. Recall, if it's continuous and differentiable, that means continuous means we have no holes, no jumps, no vertical asymptotes, and differentiable means we have no cusps. This is a smooth curve. That's the technical word is that's a smooth curve. No holes, no jumps, no vertical asymptotes, and no cusps. If we have that, and then we have the partition, then we may construct the Riemann sum. Remember, the Riemann sum is the sum as I goes from 1 to n. The Riemann sum is f of c sub I times delta x. Since this is a regular partition, we don't need to specify delta x sub I. They're all the same size. So this is a Riemann sum. And we recall that if we take the limit of this Riemann sum as n goes to infinity, that is by definition equal to something called the definite integral. We don't yet know how to compute this expression, but we will by very soon. But the limit of a Riemann sum that's the definite, by definition, that is equal to this definite integral. The integral, we read this as the integral from a to b. This is the lower limit of integration. This is the upper limit of integration. And this a and this b are the same a and b from the original interval over which the function is defined. Again, we don't yet know how to compute this value, but whatever this number is, this is a number, and this is a number, whatever those numbers are equal to each other. What we're going to talk about now is how to compute this expression, the way to compute this expression. So when we find out how to compute this expression, that means we also know how to compute this expression, and that's going to be important for us going forward.